All right. Well, happy Wednesday, everybody. I'm Joseph Fritz, the Executive Director for the Investment Casting Institute, and I want to welcome you to our webinar today. So, what I'd like to first off let you know is, unlike most of our webinars where we have you all muted and you're locked out until the end, our guest speaker today would very much like you to interrupt with questions and make this more of a dialogue. So I encourage you to please do so. You are responsible for the control of your microphone, so make sure it's off if you're not talking, and feel free to pop on and say hello. Anyhow, today's speaker is Vivek Saxena. He's the founder of Factory Twin, which is set up to simplify factories and unlock productivity. Factory Twin is a factory analytics software platform which helps manufacturers gain vast efficiencies, exploiting the data their factories already have in multiple online and offline formats using predictive and prescriptive analytics. This platform has won both Phase 1 and Phase 2 of the prestigious National Science Foundation Award for Small Business Innovation Research. So I'm really excited to hear about this. We did hear from Vivek at a prior business and leadership development conference, and I'd love to hear more from him today. Just a little bit about Vivek. Previously, he held a number of roles at Pratt& and Whitney, including chief engineer, plant manager, supply chain director, and general manager. He was also vice president and practice leader at ICF Aviation and president and CEO at Mooney International. Vivek holds a PhD in applied math from the University of Cambridge in the UK, obviously. And with that said, I'd like to turn the comm over to Vivek. Vivek, it's all yours. Thank you for joining us today, Vivek.
Well, thank you, Joe. Delighted to be here, and welcome to all the participants. I'm glad you have found time to listen to this, I think, a very important topic, becoming more and more important in manufacturing space, and a lot of progress being made, and almost becoming a competitive imperative in the industry rather than nice to have. So again, thank you, Joe, for your very generous introduction. I hope to spend about 45 minutes speaking and then have Q&A. And as Joe mentioned, if you feel a burning question in the middle, please feel free to raise your hand. And I would love to have this discussion to be interactive rather than just a one-way lecture. So I'm going to share my screen and just go over some PowerPoints, and also we'll be showing some videos. If you have any trouble hearing any videos or seeing the PowerPoint, please do let me know. So here we go. I hope the PowerPoint is visible to you all. We're going to be talking about how factory data analytics can help you improve your shop KPIs by double digits. So when I say shop KPIs, at the end of the day, the bottom line are four major KPIs that every shop cares for. They are throughput, profitability, cash flow, and on-time delivery to the customer. I mean, there are a bunch of other metrics that people track, but shops' well-being depends on these four metrics. So when we talk about any solution, whether it's a software solution, any automation solution, any equipment-based solution, it has to see the needle move for one or more of those metrics. And what I'm going to demonstrate to you today through our demo videos and the example customer cases, that indeed using factory data analytics gives you double-digit improvement or more in those critical shop metrics. So to begin with, this presentation is going to be very sort of flowing in this manner. I'm just going to be talking about, why should you listen to me? Who am I and what do we do? Then go over some factory analytics basics. Go over why adoption is slow, particularly among small and medium-sized companies, and how to begin. Then we'll show some use cases and demo videos using our factory analytics platform. And then we give some examples of our customers that have employed factory analytics and shown significant results, and then Q&A. So what is Factory Twin? So our company Factory Twin has been active in this space for a while. I've been in industry for over 30 years in manufacturing. I started this company Factory Twin in 7 years ago, and we have been working with our customers that range from raw material provider, fastener provider, all the way to large assemblies like ejection seats, electronic warfare systems and Joint Strike Fighter program, or engines. So we are pretty deeply embedded in the value stream for manufacturing, particularly in aerospace, but also in medical devices and other industrials. This is our team. We are based in Hopkins, Minnesota. The team, you can see from demographics, we have some very experienced uh, operations manufacturing operations executives, uh, computer science, data science experienced people, and people from Boeing, RTX, some of the larger companies, medical device companies like cardiovascular devices, etc. So that's our background. And then what is factory digitalization and analytics? Because it's important to mention that to some level, most factories do use data. And the question is, are they truly a data-driven organization, or are they just sort of swimming at the surface and just touching upon factory data without really exploiting the superpower that they have at their disposal? So this visual kind of describes the various levels of digitalization or experience with analytics you can have in a shop. So it's a very conceptual chart. So notionally, y-axis represents the scale and complexity of a factory. So as you go up on y-axis, it gets more and more complex, more assemblies, bigger factories. And at the lower end is the less complex factory. And I'll go into the details of how to define complexity of a factory. On the x-axis, we say, how much are you a data-driven operation, and what kind of tools you need to be a fully data-driven organization. So you can see inside pretty much most companies that have ERP system, the bottom left circle here, generic visualization tool, people have some kind of dashboard. And if you have a dashboard where you, if nothing else, you're doing really lagging indicators like on-time delivery at the end of the month or at the end of the quarter, you are using data to some extent. You're not using the data to improve your factory. You are kind of describing your factory as is. So that's what we call descriptive analytics. And so descriptive analytics in the form of custom dashboards to visualize your whatever Excel sheet or ERP system or MES system, that's one level of digitalization. Then you can get to the next level, where you're starting to do some predictive analytics, and you have tools available, again, Power BI, Tableau, there may be others that you can use that take the data or ingest the data from your ERP system and then build some analytics to give you some more details on how the factory is running or what could be happening in the near future. So scheduling, for example, is a data analytics tool. It uses the history, it looks at the bill of materials, looks at the routing standard times, and predicts how you're going to be scheduling your shop and when you're going to be delivering. So those are generic analytics tools. Then you have single-use custom software. So you often hear about somebody selling a software for, let's say, inventory management or advanced scheduling. So those are single-use custom software. They have some descriptive and predictive analytics built into it. And then you have more generic MES and ERP modules. As an example, if you think about SAP ERP system, they sell a module called IBP, Integrated Business Planning tool. And so that's a little bit more detail, a little bit more, let's say, involved in terms of analytics, but they work with the ERP system they were meant for. So these are various things that you could be doing or you may be doing at this point. And please feel free to interact. And if you do one of these things or wanted to do something and you found a problem, it'll be nice to have a little discussion on that and at least get your opinion on your experience. So that's that. And then the really on the right hand side on top is what I'm going to be mostly talking about is the digital twin technology, which allows you to do truly data driven manufacturing. In other words, every decision you make on the shop floor, whether it's about medium to long-term planning, whether it's for execution, whether it's about dynamic scheduling. You have your scheduler gives you an output which tells you what part should be running on what machine with what operator, and the supervisor comes in, 3 operators call in sick, 2 machines go down, some supplier part didn't show up, some parts go on quality hold. Now what do you do? So those kind of dynamic scheduling decisions can be made using digital twin as just as an example, but there's much more that can be done. So factory digital twin is the ultimate in factory analytics, and it allows you to do data-driven manufacturing in a truest form. And for every decision on the shop floor, you have data and you can justify it. Now, another thing is you don't have to go from one bubble to the next bubble to the next bubble. In other words, you don't have to go from custom dashboards to Power BI to single use to factory digital twin. Because you could go straight to factory digital twin because computing power these days is so much, and digital twins have been made so user friendly that you don't necessarily have to go through all these other steps. So you can leapfrog, and that's what technology generally allows. It allows you to leapfrog, the past or the incremental changes and go to what is truly going to add value to your business. Any question on this chart? Any comments? Your personal experience? If not, I'll keep going. So what is the scale and complexity in factory operation? So here's a single slide that we send to our prospective customers when we onboard them, because we want them to start thinking in terms of data. If you talk to people, well, what do you do in your factory? And typically they'll say, well, we do composite parts and we have a vertically integrated facility and we have automation and we can do so much. We have so many operators. That's all good and that's relevant knowledge. But when you talk about factory digitalization, you have to think in terms of, various types of data within the factory. For example, how many active sales order line items you have at a given time, or how many jobs do you have at a given time? How many finished good part numbers do you have? How many platforms? How many customers, part families, equipment count, outside processes, how many outside vendors? Because all this defines a scale of a shop. So the numbers that you see here is typically for a $25 million shop. So you would think a $25 million shop with, maybe, well, actually, it's a bigger shop because it had 150 major pieces of equipment. But a small shop, which may be between 10 to 100 million, can be pretty complex and very large in scale. So we're not talking about the complexity of the part you make, it's the complexity of the processes to make that part. So that's the scale. And then in manufacturing complexity, what factors constitute the complexity, like your bill of material depth. So if you're making a large assembly which has multiple levels of bill of material, obviously it's going to be more complex because you have to worry about making every level of component or buying every level of component, bringing it together. So the deeper the bill of material, the more complex your shop is. Again, router steps. How many router steps do you have? If you have a simple machine shop with 5 router steps, which you just do some prep, some machining, some deburring inspection, that's pretty simple. But if you're doing a router step that go to 20, 30, if you're making electronics with 200 steps in your traveler, that's a complex shop, right? But even 10 steps can be pretty complex. In most of castings, forging operations, very complex. You have parts of the operation which may be automated, part of the operation which are not maybe manual, not even mechanized. And so it becomes pretty complex. And then whether your demand is going up or down, is there a lot of fluctuation? How many new products you introduce every year adds to the complexity. And then you have to think about what are your data streams. So you may have ERP system, MES system, QMS, CRM, Excel sheets offline, IoT data, sensor data, all that, right? So you can see if you can put this basic information on one sheet, you can immediately start to compare two factories and say which one is more complex than the other. So this is how we look at complexity of a shop and the scale of a shop. And the more complex and larger scale a shop becomes, harder it is to try to do, make decisions just, by pulling something out of your hat or from experience or your gut. You need to have good analytics to make decisions and as complexity increases. Any questions so far? No? Okay, we'll keep going. So why is it so hard to get started? Even larger companies, we work with mid-cap companies, small companies. Our smallest customer is a $10 million shop with 32 operators, and our largest customer is a multi-billion-dollar company. And the fact is that even a multi-billion-dollar company is made up of smaller shops, and they come across the same issues that small companies come across. And so when I say why is it so hard to get started on the digitalization or factory analytics journey, it's applicable to all shops. First one everybody will tell you is because is the lack of internal talent. And 5 years ago, you could say, to do any of these things, I will need to have maybe 10 years ago, we would need a data scientist to do all this stuff. Well, now you don't have to have that. And then there's low code, no code application. The example I'm going to give you with our platform, which is Factory Twin, you'll see the same thing. It's you don't need to have an expert or data scientist to use these tools. Second is multiple sources of data. It's not easy when you go to a shop to actually get your arms around every piece of information on the shop floor. And so the visual on the right here shows you that you can have data coming from all these different sources, from your PLCs, SCADA, sensors, MES, ERP, financial system, Salesforce, CRM system, maintenance system. And when you look at this, they sometimes wonder, does anyone know what's going on in a shop? Because there's so many sources of data, so many functions. As soon as you become, um, you know, move away from being a garage machine shop in a garage, things gets complicated. And you have so many sources of data. And if you don't have all these sources of data integrated, you really don't know how the shop is running. So that's why I strongly recommend not going for these, single point custom solution that we showed in the previous chart about various ways to digitalize, because again, you're creating another silo. You want everything integrated so you have a single source of truth, a complete and single source of truth by integrating all those data systems. And if you do that, that's a big, big win right there. Because now you're playing to a single sheet of music. When buyer is placing an order or negotiating with a supplier on the need date, it's exactly what the production floor needs. It's not two different things because shop floor is diverging from your ERP predictions, right? So having this all integrated is very, very useful. Third barrier we hear from customers is trust in data. Yes, we have data, but do I really trust it? So obviously, companies have to look into what their standard methods of collecting and archiving data are and how good they are, and do an inventory of data and do some data integrity checks. So that's another barrier that are mentioned. And then next is yes, I can do all this, but the analytic solutions are so expensive. When we talk about digital twin and you Google it and you come across these big companies that offer this, and they will not do anything which is not multi-million-dollar in service fee and may take less than a year or so. So that becomes a barrier in itself. However, I think the place where we are at, that is no longer a barrier either, because there are companies like ours where we have very affordable and practical solutions, and it takes a few weeks to implement and realize the benefits of factory analytics in 3 to 6 months. So you don't necessarily have to worry about that. So it's kind of an outdated concern, but still people have this concern. And finally, leadership culture. Um, Traditionally, I mean, most of you have been in manufacturing for a while. Um, the manufacturing leadership kind of it's it's almost like a sport where you use your muscle as a reflex, where it's a brute force type approach where lots of tribal knowledge becomes handy, where there's a lot of experience with your shop becomes handy, and people don't use data. And the culture kind of encourages that, the hero worship culture, where a hero comes in and saves the day or knows everything about the shop floor. Well, that's not something that really works at shops to become competitive and have full input and participation from all their team. So that culture is sometimes a barrier as well. So this is just list a few things which come to top of my mind by talking to customers and making presentations at these trade shows and conferences that I've come across. Any questions or people would want to add anything to any of these barriers that they see might be a problem in implementing factory analytics? Okay, we'll keep going. So here's an example. These are just some of the, half a dozen factories we worked with just this year. And you can see the various systems they have. Obviously, they have different ERP systems, and so that's not a surprise. But within different functions, from quoting to HR to finance to shipping, quality, production, scheduling, everybody has a different system, different stack of technologies, different stacks of tools. And then how do you expect factory A production scheduler who's doing scheduling with an Excel sheet or a third party software to be able to connect seamlessly with what's going on in supply chain, as an example. It's having these different siloed tools is not very helpful. And at the same time, expecting that ERP system will do everything is also not possible. It's not actually feasible. We know that from experience. ERP systems are primarily meant for financial compliance, and now they're slowly adding other functionalities. So this is a good view of what I call the plethora of data streams in any shop. Without integration of those different data streams, you really are siloed in what you do, and there is no single source of truth across the factory. Questions, comments?
Yep. Yeah, Vivek. So if I understand it right, Factory Twin basically goes out or pulls data from all of these sources, your ERP system, your internal, external tools, and so forth, and pulls it all together into a single place for
That
use
is
and for predictive analysis, correct?
that is correct, and that is
Yeah.
the kind of the first step. And then you have to
Yep.
apply analytics to it,
So,
right? So
so how long does something like that take just to get to that point?
So our experience is, depending upon the size and complexity of a factory that I defined earlier, it could be between 6 to 10 weeks. So most
Mhm.
complex, we're working with a fuel cell company, very, very complex parts with hundreds and hundreds of components, multiple levels of bill of material, very long routings and test results, sensor results, and sensor data all needs to be integrated. That's about 10 weeks. But a machine shop, a fabrication shop with a bunch of deburring, some special processes, and inspection, machining, fabrication, all that together, about 200 personnel shop, that could be 6 weeks.
Now, have you had experience with foundries at all? Have you used the system with an investment casting foundry, for example?
We have a couple of discussions going on with actually ICI members right now.
Hmm.
And that came out after the presentation at the ELDC earlier in the year. We have worked with other raw material suppliers that make plates, blocks, bars,
Hmm.
etc.
All right, very good. Thank
Okay.
you, sir.
Yep. And so Factory Twin is a very generic platform. It works with it even works with chemical processing. So it doesn't even have to be discrete manufacturing. Our customers are in composite space, in raw material space, in, like I mentioned in the first or second slide, machine space, assembly, and so on. Thank you for the question. Let's keep moving. So this is exactly what you were saying, Joe. We integrate all these sources of data, and you may even have multiple sites, and that it becomes very interesting. If you have multiple sites, you do want to integrate your spend, right? If you're a supply chain organization, you want to see how you can leverage the buy at one place and the second place together. So you need to be able to aggregate. So Factory Twin looks at all the data sources in a factory, integrates it, and then integrates multiple sites together to build the Factory Twin, which could be put in cloud or on-prem in a server. And then the front end becomes activated, which has three major modules: sales and operations planning, sales and operations execution, which is day-to-day and decision making, and digital continuous improvement. That's for lead time reduction, cost reduction, on-time delivery improvement, all that stuff. And then it comes with additional functionalities like Factory Validator for data, integrity checks, scenario analysis. I'll go over that in a minute. And dynamic scheduling. I talked about that earlier. Optimizer for inventory or whatever objective you want to optimize to. So this is in one page what Factory Twin does. Integrates all sources of data and gives you insights on the front end, which is very easy to use. And it comes in three modules: long-term planning through sales and operations planning, day-to-day execution through sales and operation execution, SNOE, and then overall improvement of cost, delivery, lead time through digital continuous improvement module. Okay. So here's an example. Why is it one of the really important thing that comes out of doing something like this is you can experiment on your computer model of the factory. So you're building the computer model of the factory by integrating all those data sets, and the model is connected real time to your data streams within the factory. So as parts are moving and parts are being shipped, parts are being received, it's reflected in the model. So if you have that live model of your factory, you can do experiments without actually taking the risk of going to the shop floor and trying it out. So it's multiple things you can do. You can turn the knobs, you can add demand, you can change jobs, you can modify jobs, you can add, remove operators, move them to different shifts, do cross training. You can add machines, you can relocate machines, you can plan for scheduled downtime of the machine, remove the machine, prioritize jobs. Remember how many times your customer calls and says, this is a hot part, needs to move fast for whatever reason. And you can prioritize and the scheduler can give you the output. But you need to be able to understand, what does that mean? What does that expediting of a single job doing to your rest of the jobs? And in fact, for other jobs, for the same customer who asked for that to be expedited. And you can do it at the push button, so you can know immediately what is the impact if you prioritize one job over the rest. So all this can be done very, very quickly. Things that used to take weeks or months, or sometimes people never bothered and just use gut feeling, it can be done in seconds or instantaneously. You can change factory shift schedule, modify supplier delivery. So shift schedule, and a good example is this is the time when people go on hunting trips, right? So I remember when I ran shop, I knew there was a group of operators that would go out for 3 to 4 days and won't be coming for work after Thanksgiving. So you can plan for it now and say, well, what does that mean in terms of overtime or maybe alternate shift I need to run in the future? And you can do that experiment on the computer before you even decide what to do, and before you go to the shop and survey the people on who's available for overtime or not. And as I mentioned, the tool should be able to check for the data integrity. So Factory Twin actually, when it runs, it checks where you have incomplete data. It tells you exactly where you have incomplete data and when you need to fix it. So having data trust is very important. So any questions so far? We are 30 minutes into this call, and then I have gone over most of my slides. I just want to show some use cases through a demo of Factory Twin. Any question before we jump into that?
I have a question regarding multiple data streams and origins. So how do you deal with the complexity and problems with having different formats? Excel spreadsheets, you've talked about ERP systems, Excel spreadsheets, uh, other tools that are used that are not within the domain, integration of QMS data. How do you get all of that into the digital twin? Does that happen on a continuous basis? Does that happen, on a periodic basis? How is that monitored? And how do you assure the data integrity through those different pipelines?
Yeah. Okay. Great question. So here's what happens. What Factory Twin does, there's this kind of a technical term called ETL, extract, transform, and load. So Factory Twin has its own ETL algorithm, which has been designed to ingest data from both structured and unstructured data sources. So in other words, it's not just going to take data from something like an Excel sheet or a SQL database. It can also ingest data from Word documents, PDF documents, unstructured data. And so that technology is not new anymore. It's just that we are bringing it in a manner that is much more user friendly and easy to and quick to implement. So the way it works is this, Paul, to your question, you basically want to convert all the data streams into a SQL database. Why SQL database? Because it is the industry standard for a robust relational database, which can be easily queried. There's standard universal languages to query it. It comes in various flavors, but any SQL database is easiest to work with. So Factory Twin's backend is a SQL database. And so in the ETL phase of the project, where we integrate all these various sources of data, we convert all that data into SQL database when we connect to those data streams. And so there is some technology involved in converting unstructured data into SQL or converting Excel sheet or CSV data into SQL, but that's done one time. Because once we understand what the format and the source of data is, the ETL algorithm takes care of that and it's automated. So you're not going and changing things every time. Once you have connected the ETL and created the pipeline of all these various sources of data into the back end of Factory Twin SQL database, then it's automated and it just happens transparently. Does that answer your question, Paul?
Yes. So what happens when somebody throws you a curveball and one day you got a document in one file format, or today I got a purchase order from somebody in a PDF format, but tomorrow it comes through from the same customer or another customer in a different file format. How difficult is it to create a new ETL path, and how frequently can you do that?
Yeah, so for that kind of scenario, we can do some, sort of like a local transformation. So basically, we would look at, looking at your historic PO format. So if they come in various different formats, and by the way, if they're customer POs, are you not entering them in ERP?
Yeah, I
Okay.
I guess that's part of it is where do we, how much flexibility each data stream has to have its own origin and ETL, and I'm just asking whether and
Yeah.
how flexible things are in order to readjust when you do. You may have multiple sources, and certainly avoiding hand, keying of a PO would be valuable in some organizations, I would think.
Yeah. So I think the answer is we could do both. There's flexibility to account for the fact that you have POs in different formats if you're not entering them in a standardized manner into your sales order line items in the ERP system. You want Factory Twin to directly read the PO. That's possible. Obviously, that will require some customization. But in most instances, if you have an ERP or MES system, your commercial team is actually converting the PO data, the relevant fields, into ERP sales order line items. And sales order line items, as long as they have these 5 basic pieces of information, Factory Twin will work. And they are what part number, what unit price, what due date, what lead time, and what customer. So if those 5 pieces of information are there either in the PO or in the ERP system, we can read it either way. Any follow-up?
Thank you.
Is that good? Yeah. Okay, cool. All right. So we'll any other questions? Okay, if not, then let's start with a use case. So what we've done here is, instead of me going into the tool and giving you a demo by clicking each push button, we have stitched them together into a video to make a use case. So I'm going to share with you 4 use cases. Each one of them is about 2-minute video. And the first one is, can I commit the lead time in the code? So it's a common problem. Order comes in, there's a price requirement and there's a lead time requirement. And typically in a shop, when a lead time requirement comes in and you say, well, can I do it in 32 days that the customer is asking for? You will look at your historic data. That's one way to do it. But is that the right way to do it? Because your product mix may have changed. Your resource constraints may have changed. You may have more or less machines. You have more or less operators today than you had 2 years ago when you did that part. So you need to do some analytics on it. Or the other thing people do is call up the shop supervisor, and they don't know any better. They know what you know, which is what was it done in the last time. So what is the analytics approach to committing a lead time? So please let me know if you don't hear the video sound, and hopefully you will.
When a customer sends a new order, it can be difficult to judge whether or not the requirements can feasibly be met on time. Factory Twin's rapid scenario analysis can help factories confidently commit to data-driven due dates. Say today's date is January 1st, and a customer is requesting an order with the following requirements. Step 1. Start by evaluating historic order lead times as a sanity check of the required lead time. Select the required part. Each dot represents a line item. The y-axis represents the lead time committed on a sales order. The x-axis represents the actual lead time for that order. The green line represents the system lead time in the ERP system, which is 33 days. The blue line represents the average of historically demonstrated lead times, which is about 34 days. We can make the following observation. The customer required lead time of 30 days is a few days less than the historically demonstrated lead times, so we need to investigate further. Historic data can be a reliable lead time analysis, as long as product mix has remained fairly stable. In this factory, product mix is expected to remain the same. However, we don't know if the resource constraints have remained stable, so we'll do some further analysis in Step 2. We can use Factory Twin's rapid scenario analysis to more quantitatively evaluate 2 potential solutions: identifying a more feasible lead time or giving this order highest priority. Let's explore the first strategy, identifying a likely lead time. Create a new simulation and add a new line item. Recall that the average demonstrated lead time for this part is about 34 days. Define a due date that is 34 days in the future. When we view this simulation, we can check the predicted delivery date of the new line item. The predicted delivery is on February 6th, 36 days from today. This means that the factory can likely complete production of this order in 36 days, given the factory's product mix, material availability, and capacity constraints. Next, we can strengthen our analysis by evaluating the impact this additional line item had on other shop KPIs using Factory Twin's comparison module. In just a few clicks, you can evaluate changes in utilization, overdue order burndown, revenue, cash flow, and the impact on other deliverables. In this scenario, you'll notice that the rate at which overdue line items accumulate is quicker at first and then slows. However, there is predicted to be almost the same amount of overdue line items at the end of 3 months' time. Additionally, we can evaluate this scenario's impact on other line items. The addition of this line item pushed back predicted delivery dates for multiple line items. However, most of these line items were predicted to deliver early, so there are few instances in which the delay surpasses the due date. The effects of this scenario are not expected to be dramatic. However, the predicted delivery date is beyond the customer requirement. Let's explore another strategy and see if the customer requirement date can be met if the order is highly prioritized. Start by creating a new scenario. Create a new line item for the proposed requirements. However, give this line item a due date far in the past. Factory Twin's algorithm will prioritize scheduling this line item above others because it is overdue. When we view this simulation, we can see what delivery date Factory Twin predicted when the line item was rushed through production. This is the shortest possible lead time for this order, given the factory's current product mix, material availability, and capacity constraints. When prioritized above all other deliverables, this line item was able to complete in 32 days. Again, let's compare this scenario's KPIs. The overdue line item accumulation is very similar to the previous scenarios. The addition of this line item pushed back predicted delivery dates for multiple line items. However, much more of these delays result in predicted deliveries beyond their respective due dates. These consequences are more severe. Even with the highest prioritization, the quickest this line item can be fulfilled is in 32 days, which is beyond the customer requirement. Based on the factory's risk appetite and customer importance, they may choose to renegotiate the delivery date for this order. Keep in mind that each factory should keep 10 to 20% buffer in their lead times to account for unpredictabilities. To learn more about how Factory Twins...
Okay, so any questions on this? So you can see this is something that happens all the time. New orders come in, you want to commit to a lead time that you can actually deliver. And this is a very easy to use, something you can do in a matter of minute or less to just go through the calculation to see whether you can commit that lead time. Any questions on this? There was a lot that went on in this video, so if there are any questions on clarification, I'll be happy to answer. Otherwise, I'll move to the next one. Okay, so the next one is early mitigation of future bottlenecks. So this is long-term capacity planning, CapEx planning, etc. Again, you can look at your model in the future if you have your demand forecast, which is the basic element to be able to predict future bottlenecks and how to mitigate those. So this is a use case for that. I'm going to start that, and please feel free to ask questions.
Factory Twin's Sales and Operations Planning module strengthens and automates a factory's long-term planning processes. Rapid scenario analysis allows users to build complex what-if scenarios. When combined, users can compare long-term planning strategies. Let's explore a bottleneck mitigation use case. Start by identifying periods of red. These areas indicate...
So let me just go over what this is. This is a heat map. On the y-axis are all the resource groups. So you can see inspection, saw, mill, polish, anneal, heat, etc. And y-axis, x-axis is the time period. And in the background, in the engine, all the calculations are happening that account for yield, unscheduled and scheduled downtime, breaks, operator stake, etc. All that OEE calculations are behind. And the utilization is basically what is the loading on a station divided by the availability of that station. So if you're running 2 shifts, you have availability of 16 hours, let's say, per day. And the loading will depend on what parts you're going to process on that station. So with that, anytime you have a red, that means you have capacity utilization, which is choking that station, which means it's overutilized. So with that intro, let's start.
Bottleneck. We can see 2 issues with this factory. In spring of next year, Factory Twin is predicting a bottleneck across many resource groups. We can also see that this CNC operator group is chronically constrained throughout the next year and a half. Let's focus on mitigating the CNC operator group bottleneck using rapid scenario analysis. First, We'll experiment with a brute force method of bottleneck mitigation. Start by creating a new simulation. Add one more CNC machine to the Minneapolis factory. Choose the date it would become available to production. Next, hire 3 new CNC operators for the Minneapolis factory. Choose their hire date. Each operator will be assigned to a different shift. Save and build this simulation. Compare the baseline simulation with the brute force scenario. When we compare the baseline factory with the brute force scenario, we can see that the CNC group is no longer constrained. Adding new resources comes at a high cost, so we may want to explore other options. Next, we will try a more cost-effective approach using existing resources. Let's go back to the original state of the factory. Notice how the saw labor group is consistently underutilized. Additionally, we can investigate the demand drivers of CNC utilization. Notice how there are 3 customers' demand driving the utilization. Create another simulation. First, cross-train the underutilized saw operators for CNC tasks. Then, level load demand for the customers driving CNC utilization. Adjust line item due dates to smooth out the demand spikes. Lastly, add overtime to each shift. Save and build this simulation. Compare the baseline factory with this cost-effective scenario. With this method, we've eliminated the CNC bottleneck. Both of these scenarios resolved the CNC bottleneck. However, the cost-effective scenario is more practical and affordable than the brute force scenario.
Any questions? So this long-term capacity planning is a regular exercise people often do in Excel sheets, but it doesn't have the level of granularity, robustness, and insights that you can get by actually doing future scheduling and looking at every aspect of what causes a capacity constraint, whether it's at operator level or at machine level. So you saw, quickly how you can do that, and you can run these kind of simulations in a couple of minutes for a normal size factory. Any questions? Okay, if not, I'm going to go to the next one. And the next one is something that factories do all the time. You always want to reduce your lead time. You always want to reduce your cost.
Factory Twin's digital continuous improvement module helps factories identify opportunities to optimize cash flow, boost on-time delivery, and increase profitability. Let's dive into a practical example of lead time reduction. Factories can improve their on-time delivery by targeting long manufacturing lead times. Identify abnormally long or variable queue time and cycle times in your historic production data. Visualize these problem areas within the context of a part's full production cycle using Factory Twin's on-demand value stream map. Now, your continuous improvement team can focus on the future.
By the way, I want to point out that for lean implementation, the very first step is value stream mapping, and it's complex. And traditionally how it is done when you put experts in a room, they put yellow stickies on the wall, they meet for 2 hours a day for maybe several weeks or several days. And then you have something that people take a picture of, put it in an Excel sheet, and it's forgotten. And what we believe is that for as is value stream mapping, all the data is available because we have the previous job history in your ERP system. So we have the queue times, we have the standard time, we have the actual times. We know how many operators are needed to run what machine. So another advantage of Factory Twin is you have a push button on demand value stream mapping capability for every single part.
Future state value stream map instead of spending weeks generating the current state map. Identify major differences in material and service supplier lead times. If there are large differences in lead times between suppliers, placing future orders with the quicker supplier can further reduce the overall lead time of a finished good. Now, let's explore a cost reduction scenario. Start by identifying a high-impact part. Targeting a low-margin part with high projected revenue can yield quick and profitable returns. Here, we see how this part's cost breakdown has evolved. Notice the sudden increase in material cost at the start of 2023. This is the critical issue that needs to be addressed. This part has one material component. In 2022, this material was purchased in a quantity of 6. In 2023, that dropped to 3. This reduction resulted in a $3,000 unit cost increase. Factory Twin leverages future demand data to project a part's future cost. If this part's material cost was reduced to 2022 levels by ordering in larger quantities, this factory would save about $142,000 over the next 2 years. Similar analyses can be done for other cost contributors. Identify labor cost reduction opportunities by examining past work order history. In this example, note how this operator, Angela, is paid a relatively high wage. Also notice how, on average, she takes longer to perform this operation than her peers. Other operators perform the same operation quicker and for less pay. Providing Angela with additional training could speed up her production rate and reduce labor costs on this operation. To learn more,
So this is just, touching on again on the surface of what you could do with lead time reduction and cost reduction, because you have all that data available to you and you don't have to do, one-off analysis. It's all available for you for every part, every machine, every operator, every purchase part, just at your fingertips. Questions? And the last video is
Factory Twins did
inventory management. So, a lot of companies do periodic inventory meetings again to get ready for it, getting all the data, aging, what inventory is getting obsolescence issues, etc., can be easily determined and do proactive inventory management in Factory Twin.
proactive inventory management in Factory Twins Sales and Operations Planning module. Manage inventory at an aggregate level or do detailed material shortage analysis. Let's step through an example of proactive inventory management. Start by categorizing your inventory into standard buckets such as details, finished goods, WIP, raw materials, and consumables. Identify a bucket of interest and investigate its aging distribution. The majority of this factory's raw material inventory is over a year old. Next, see how much of raw materials are inactive. Inactivity means that Factory Twin predicts the inventory items will not be consumed by finished good demand in the foreseeable future. In this example, about $360,000 of raw material inventory will not be consumed. Let's narrow in on our inactive raw material stock. Here's the activity status of the top 10 raw material parts by value. This purchased part is high in value and 100% inactive. This table has actionable information for all part numbers, such as last customer or supplier. Here, we can search for this purchased part's last supplier. Inventory management.
I want to speed up. So you can see you can do inventory management, all the questions you need to ask, all available to you at your fingertips. Any questions on that? Otherwise, I'll just take the last 2 slides and close the presentation. Okay. So some examples of what our customers are. So I've named the customers and their companies. So these are real testimonials they sent and agreed to being shared by us. So in this case, Tom mentioned that they were having real struggle with on-time delivery, and you can see light blue is without our solution, dark blue is with our solution. And so the lead time of part in that factory was about 3 to 4 weeks. So you can see first 3 weeks is pretty comparable. And as you go beyond first 3 weeks, the optimizer in Factory Twin knows what parts you should start work on even in the first 3 months, given the capacity available, so that after those 3 weeks, you see a dramatic improvement in on-time delivery using Factory Twin. So that's one example. Another example is, again, this is from Accurus Aerospace, which is a large portfolio of companies. And there we work with them and improve their cash flow by 50%. So that's what I mean. Using this data analytics, if you have not used before, you can see these kind of huge improvements. These are not incremental 1 point, 2 point, 10 point improvements, right? These are huge improvements, 50% improvement for this cash flow in this scenario. And then quickly, there are other benefits also. I think the biggest benefit is when we talk to people who use our software is they become a proactive organization. They're looking at early alerts on problems that are going to happen and they're preparing for it. One of our customers' testimonial, which I really cherish, was he said, of course, there has been improvement in KPIs, but the real benefit is that the tone of conversation in my leadership team has changed. Instead of every time talking about the problem that you're reacting to or are stressed out about, we are talking about things that will happen 8 weeks from now, 2 months from now, 3 months from now, and we're getting ready to how to solve that problem. We also did a survey with Aviation Week last year on what are the various smart manufacturing technologies companies are investing in, and you can see majority of them, 70% of them, are doing data analytics. Conclusions, quicker and better decision making. What used to take days, weeks, months, like VSM, like cost reduction, like inventory planning, now done in seconds. Double-digit improvement is a norm. Some customer testimonials on the right that I kind of alluded to in the beginning. So with this, I'm going to close on my presentation and open for the last few minutes for the Q&A. Joe, any questions? Anybody?
Yeah, thank you, Vivek. I think a couple times this year we've heard people come in and talking about artificial intelligence and how that's going to play a significant impact in our industry. And clearly, Factory Twin also plays a role. Can you give me an idea of how they would work together or how they would support each other?
Yeah, so that's a great question because this is a really contemporary topic. Everybody's talking about it. So first thing I should say is that Factory Twin already has AI methods built into it in the predictive analytics. And those are not generative AI type stuff. It's really the mathematical aspects of AI, like machine learning, neural networks, where we do predictions. So that's already built in the predictive engine for certain capabilities. But I think where this will become even more powerful is in answer to your question, is if generative AI wrapper could be built around Factory Twin, which we plan to do in about, I would say 18 to 24 months, because it takes some effort and you want to do it in a manner which is secure and reliable. Is if you build a generative AI wrapper in this, then Factory Twin is able to understand conversational words rather than technical words, right? So instead of saying, tell me how inventory turns improve, a user could say, I need to improve my profitability, or I want to improve my cash flow. What do I do? And the Factory Twin interprets that the words spoken using generative AI and then translates into mathematical algorithm to give you the answer. So I think it'll be very exciting, and we're looking forward to integrating generative AI with Factory Twin in the future. But until then, we are already using the mathematical aspects of AI, like machine learning, in the predictive analytics of the engine behind Factory Twin. Thanks for that question. Any other questions?
Well, looking at this tool, Vivek, I mean, I think my question is, if I were running a foundry today, who would be the right people to have access to it and use it, and how much training is involved to get them so that we get basically a return on investment for something like this?
Yeah, so I think this is perfect, right? That's the kind of questions users should be asking. What is my ROI on this? In addition to double-digit KPI, who are the people that it helps? So basically, it's a decision-making tool, right, for both execution and planning. So typically, it's used by every function in a factory. So you may have buyers. So certainly buyers would be using it, materials management people will be using, production scheduler will be using it, planner would be using it, financial analysts would be using it, production supervisor would be using it. So it's not a tool that is used on an interactive basis by the shop floor labor, but by supervision and support functions. although the output from them often drives what the blue-collar labor does on the shop floor. So again, to give you a very concrete answer, in a 100 personnel factory, our experience is typically between 15 to 20 people would be using it and really cutting down on their mundane, offline, repetitive, boring tasks so they can focus on real value add creative decision making. Any other questions?
Hey, thank you for the presentation. Wanting to understand, so in a scenario where you're looking at kind of long-term planning goes into place, and you're following along with the plan and things are moving along, and then some pesky customer comes in and doubles an order on you or drops in a surprise order. How hard or how difficult is it to make the changes to that on the spot to see what does that do and how does that change life for everybody else?
Yeah, it's actually very quick. The first use case I showed you about committing to lead time on an RFQ, that basically went through that. So you can run that scenario analysis by adding a line item. And not only that, if it's an early kind of forecast or early handshake with your customer about, yeah, we're going to place an order for X number of pieces, we want it delivered by this date, you can negotiate in a database manner because you can go into Factory Twin and add that line item and play around with its due date and play around with its quantity and say what is the easiest way for you to handle that without coming across any capacity constraint. So absolutely, this is one of the biggest benefits of Factory Twin because you can add demand, you can take out demand, you can take out supply, like say resources, and do experiments on Factory Twin in a matter of minutes or less, depends on the size of your factory. So absolutely, you can do all that. Does that answer your question, Brad, or anything else?
Thank you. Yes, thank you.
Yeah. Okay. Any other questions? I think we're running out of time, so I really want to not take too much time and beyond what was committed, and would like to thank you all for joining. You can contact me offline, connect with me on LinkedIn, send me email, whatever makes sense. And I would also like to thank ICI and Joe and Nora for organizing this. Thanks for having me. It was a pleasure.
Well, thank you very much for that. It was a very informative talk. Well, also want to thank those folks who joined us today and are still with us. Just a reminder, our next webinar is going to be on December the 11th, and that'll be me. I'll be just doing our 2024 year in review, and we'll also in January do a forward look to what the 2025 program looks like. So hopefully you could join us on December 11th at 1 o'clock Eastern. I look forward to seeing you all then. Take care and have a great Wednesday. Bye-bye now.